All right, so today's notes are on absolute value equations. Our content objective is to write and solve absolute value equations, and our language objective is to use the correct terminology to describe those and the process to solve them. So we're going to start with defining absolute value. So I believe you guys have seen this before, but we're going to talk about absolute value of a real number. And that is the number's distance from 0 on a number line, and it is written as the absolute value. So tall line, whatever inside the absolute value, another tall line. So just two tall lines around something indicate the absolute value. So with this, a quick example of what this could mean, if we had the absolute value of x is equal to 5, that means we know the distance of this value is to 0 is going to be 5 units. So the distance of this number to 0 is 5 units. And there's two ways that this can be true. So if we have a number line here, put 0 in the middle, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here I know the x can equal 5 because the distance from 0 to 5, the distance here is 5 units. But x could also be equal to -5 because the distance from -5 to 0 is also 5 units. So whenever we're solving absolute value equations, we're going to end up with two equations. One where what's in there could be the positive distance, or one in there where it could be a negative distance, because when the distance can't actually be negative, the distance is always positive. So it could be in the positive direction or the negative direction and just have a distance of 5 in either way. So I'm going to write this out in words. These three dots that I'm drawing right here indicate therefore. And so I'm just going to say therefore absolute value can only equal positive numbers. Because there can never be a negative distance. So when something is inside an absolute value, when you take it out, it becomes positive because there's never a negative distance, there's only positive. So what's inside can never be, or it can never be equal to a negative number. So when I'm solving, I'm going to set up two equations, one where I take it out and set it equal to a positive, one where I take it out and set it equal to a negative, because what's in there before you make it absolute value or make it positive, since distance is always positive, you have to account for two possible ways that you could have a distance of 5 in the positive direction or in the negative direction. So we're going to do an example together. What is the solution of absolute value of 2x minus 1 equals 5? So we're going to do this. I'm also going to have us graph the solution, but we'll get there in a second. So our first step is always going to be to isolate the absolute value. And I'm going to abbreviate absolute value as ABS dot VAL dot. That just means absolute value. So in this case, when I say isolate the absolute value, what's inside the absolute value is the distance. So we always have to find out what the distance would be or what this will be equal to without anything else around it. So you always have to isolate the absolute value first. In this problem, this is already done. So we don't have to do anything. So we're going to go on to step 2, which is going to be set up two equations. One for the positive distance, or one for the positive direction, and one for the negative direction. So we're going to account for the two possible ways we could get a distance of 5 here. If it's going to be in the positive direction, so you have 2x minus 1 equals 5, or 2x minus 1 equals negative 5 in case it was a negative, or in the negative direction, distance of 5. So then we're going to solve both equations. So this is not very different from just solving normal equations. The only added steps are isolating the absolute value and setting up two equations. So I'm going to add 1 to both sides. I get 2x equals 6. Divide both sides by 2, and I get x equals 3. So there is one solution there. Same steps here, but since it starts as a -5, -5 plus 1 is actually -4. And when I divide that out, I actually get x equals -2. So these are my two solutions. I'm going to again show us how to plot these on the graph. So since these are just individual points, all our answer is going to be is just simple points on a number line. So if I put 0 here, 1, 2, I'll do 3, 1, 2, 3. My answers are just going to be filled in circles at those points because those indicate the two spots that I have solutions for this absolute value problem. You can also check your answer. So if you plug these back in, 2 times 3 is 6, minus 1 is 5, absolute value of 5 is 5. Or we could do -2 times 2 is -4, minus 1 is -5. Absolute value of -5 becomes positive because the -5 is still a distance of 5. So the answer is 5. All right, I'm going to flip the page and do one more example, and then we'll do a bunch of practice problems in class. So one thing that we're going to have to do in some absolute value problems that get a little bit trickier is check for extraneous solutions. We really only have to do this when there is an x outside the absolute value. So we have to do this because then if we end up getting a negative value of x, sometimes that will, when we solve it all out, we end up getting an absolute value is equal to a negative number, which we know is never allowed. The distance can never be negative. It can be in the positive or negative direction, but the distance itself is negative, never negative. So we have to check when we have an x outside that we don't end up with a extraneous solution. Some of you might be wondering what an extraneous solution is, so I'm going to give you a definition really quick. An extraneous solution is a solution that is derived or gotten, solved out for from the original equation, or from an original equation, that is not a solution of the original equation. So it's not actually a solution of the original equation. So what this means is you properly solve out and you get this answer, but then when you plug it back in, it doesn't actually work. So it's something that you correctly solve out for, but is not actually a solution when you check it back again. So our example we're going to do for this, we're going to solve absolute value of 3x plus 2 equals 4x plus 5. So we're going to do the same steps again. So step 1, we're going to isolate the absolute value. So again, I'm checking there's nothing being multiplied here, nothing being added here. So I can just go right ahead and check that step off. So I'm going to go on to step 2, set up two equations. One for the positive distance, one for the positive direction, one for the negative direction. So I have to account for if the distance was in the positive direction or the negative direction. So I end up with 3x plus 2 equals our original problem, 4x plus 5. My other one is going to be 3x plus 2. So notice what's inside here doesn't change. It's equal to negative and then parentheses 4x plus 5. You could skip this step and write this as negative 4x minus 5. So notice that it changes every sign that's here. It doesn't make them all negative, it just changes all of the signs. So if this was 4x minus 5, it'd become negative 4x plus 5. You're switching all the signs, not necessarily making them all negative. So when you're setting up the equation for the one that accounts for the negative direction distance, make sure you make every sign different or put a negative in front and distribute that negative in. to change all the signs. Either way will work. Now we're going to solve out per usual. So I'm going to start with the one over here. So I'm going to add 2 to both sides, and I get 3x equals 4x plus 7. Subtract 4x from both sides, and I get negative x equals 7 divided by negative 1. There's a lot of different ways to get that. If you did it differently, that's fine. X equals negative 7. So that's one possible answer. Oh, I messed that up. Sorry. Ignore that. I did this wrong. You subtract 2 and you get 3. I incorrectly solved. You're not adding that 2 to move it. It's already being added. You do the inverse operation. You are subtracting 2. Sorry, I'm not paying attention to what I was doing. So I subtract 2 from both sides. I get 3x equals 4x plus 3. Subtract 4x from both sides. Negative x equals 3. Divide by negative 1. X is equal to negative 3. So that is actually a negative 3. My apologies. Hopefully that didn't throw you guys off too much. All right, now we're going to do the same steps here. So I'm going to subtract 2 from both sides. So I have 3x equals negative 4x minus 7. Then I'm going to add 4x to both sides, and I get 7x equals negative 7. Divide both sides by 7, and x equals negative 1. So right now, these are my two answers or solutions that I believe will work or could potentially work. But because I have this x that's outside the absolute value, I need to check for extraneous solutions. And I do that by plugging back into the original equation. So I'm going to plug these each back into the original equation, so our original problem. So I have 3 times negative 3 plus 2 absolute value equals 4 times negative 3 plus 5. If I solve that out, 3 times negative 3 is going to be negative 9 plus 2 equals negative 12 plus 5. Keep solving this out. I get absolute value of negative 7 equals negative 7. And then absolute value of negative 7 becomes positive. So I get 7 equals negative 7. That is not true. So this one is extraneous. I cancel that one out. It doesn't actually work because 7 is not equal to negative 7. That's not the same value. So that one is not true. So I'm going to try my other one now. I'll draw a little line here so we can see that these are separated. I have absolute value of 3 times negative 1 plus 2 equals 4 times negative 1 plus 5. Sorry, that's a little crunch there, but hopefully you know what I'm writing. 3 times negative 1 is negative 3 plus 2 equals 4 times negative 1 is negative 4 plus 5. Keep going. I get negative absolute value of negative 1 equals 1. Absolute value of negative 1 is 1 equals 1. That one does work. So my only actual answer or solution is x equals negative 1. So your last step is eliminate extraneous solutions. Sometimes both will work, sometimes it will not. Sometimes neither will work. But in this case, x is equal to negative 1. That one works. Negative 3 does not. So that is all we have for today. Make sure you write down any questions, comments, concerns you have so we can go over them together in class.